Good day, students. Today we are starting with the second unit of the ninth class, that is matter around us pure? This is second unit of the ninth class. Now, what is matter? We have already studied it in the first unit. Matter is anything which occupies space, possesses mass, and works when it has some extra energy, or it can be felt by any of our five senses. Then, now the question is whether the matter around us is pure or not. So it is true to say that matter around us nowadays is not pure. The air we breathe, it is highly impure, it is contaminated with many poisonous gases. The water we drink, it is also contaminated with many poisonous salts and the other contaminants, the microorganisms, even the you can say the dirty things. They are from the sewer supply. Sometime water is supplied in this contaminated form to our homes, and then we have the food we eat that is also contaminated. They are being stormed by number of chemicals which are used as a preservative, but their quantity is so much high that it affects our internal organ, it affects our kidney, it affects our liver. So we can say in law that matter around us is nowadays not in the pure form. So it is our wiseness how we consume this matter, how pure this matter we take. Because we have seen that use of RO and use of aquaguard that has dominated these days only because the water supplied by the municipalities or water which is coming out of the different sources from the earth, that is contaminated. That's why the RO system or aquaguard that has been used. Similarly, the food, the flour we take from the market, it is heavily loaded with the chemicals which affect our internal organ, which reduce our lifespan. So we have to be wise enough to take these material which are essential for our life. The air we breathe, the food we take, the water we drink, it should be in pure form, and it is our wiseness how we use that. And so matter around us nowadays is not pure by any means. So what are pure substances? Matter is anything we know. Now what are pure substances? Pure substances are those substances which are made of particles of only one type. They should not be mixed with particles of other type, or in other words we can say the elements, they are pure only if they cannot be decomposed into nor be built from simpler substances by ordinary chemical or physical means. So pure substance, it is made up of the particles of only one type, one kind of particle. They are present in pure substances. So we can say they contain particles of one type only. So these may be element and compounds. They should not be contaminated. So these are the pure substances. As we know, element, they are made of three. They are of three types. They are metals, non-metals, and metalloids. Metals, you know, they are good conductor of heat and electricity. They have metallic luster. They are malleable. They are ductile, and they are thermally stable. And They are good conductor of heat and electricity, and they are lustrous. So these are the metals. And metalloids, they have the properties in between metals and non-metals. Non-metals, they are not so lustrous, and they are brittle, and they have the earth origin. They are generally derived from the earth crust, and they are made up of the inorganic materials, like you can say these are the elements of generally P block. The elements which are lying on this side of the periodic table, they are actually non-matter: nitrogen, phosphorus, sulfur. Okay. So these are the non-metals. Then we have metalloids. They have the properties in between metals and non-metals. For example, we have the barium, beryllium. We have aluminium. It is having some metalloid character. Tin is having metalloid character. Antimony is having metalloid character. So these are some metalloids. Then we have the pure substances, the compounds. Compounds, it is formed by the combination of two or more elements in any ratio, in fixed ratio by weight. They are of two types. They are organic compounds. They are the hydrocarbons and their derivative. Hydrocarbons में alkane, alkene, alkynes, all they come under this category. Examples are alkanes, alkenes, alkynes, arenes, etc. Then we have inorganic compounds. They are generally of earth origin. They are obtained from earth by digging holes in the earth crust. Or these are inorganic compounds. They are made up of any of the known 105 elements, 122 elements. Their examples are NaCl and all minerals, ores. They all come under this category. These are the inorganic compound, and we come to these are the pure substances. Then we have impure substances, which are contaminated with impurities. They are generally mixtures. Mixtures, they are of two types: homogeneous and heterogeneous. Homogeneous mixtures are those mixtures which have uniform composition throughout, while heterogeneous mixtures, they don't have the uniform composition throughout the mixture. Now we come to the solution. Solution is a homogeneous mixture if it has completely dissolved solute in it. What is solution? It is defined as the homogeneous mixture of two or more chemically non-reacting substances whose composition can be changed within certain fixed limit, that is called as solution. So solution is a homogeneous mixture of two or more chemically non-reacting substances. For example, when sugar is dissolved in water, it gives us solution. If sugar remains partially dissolved, then it will be giving heterogeneous solution. If sugar is completely dissolved in water, then it will give you homogeneous solution. Now, what are the methods, what are the types of solution, and what are the parts of solution? If we want to know what are the parts of solution. Solution always have two parts. Number one is solute. Solute is the substance which is dissolved, and solvent is the substance in which solute is dissolved, or we can call it as minor component. Of the solution, or it is the substance which is dissolved. Then we have solvent, the liquid in which solute is dissolved. It is the major component of solution. Now, example is when sugar is dissolved in water, then what is sugar? Sugar is solute and water is solvent here. So these are the parts of solution. First part solute, which is dissolved, solvent in which solute is dissolved. Then we come to the next types of solutions. Depending upon the number of components, they are binary solution. It is two component solution. As we saw above, sugar dissolved in water, it is two component solution. One component is sugar solute, another component is water. So these are binary solutions. Sugar in water is the best example. Similarly, we have ternary solutions. They are three component solutions, two solute plus one solvent, or reverse, one solute plus two solvent. In this case, we can take the example of sodium chloride and sugar dissolved in water. Here we have the example of sodium chloride dissolved in water alcohol mixture. So these are ternary solutions. Similarly, we can classify quaternary. We have four components, 3 plus 1, 2 plus 2, or 1 plus 3. So there are three types of solutions. They have four components in their solution state. Pentary solution will be having 5 components and so on. They can have the classification on the basis of number of components present in the solution. So this is our classification based upon the component. Second system is on the basis of physical state of solvent. Solutions, they are of three types. Number one, liquid solution, where solvent is liquid. For example, sugar dissolved in water, solvent is liquid, they are liquid solutions. Gas dissolved in water, liquid solution. Solid dissolved in water, sugar in water, liquid solution. Gas in gas, liquid solution. So they are of three types. Then we have next, we have solid solutions, where solid is the major component or it is the solvent, in which it is again of three types. Gas over solid, you can have metals which have adsorbed hydrogen on their surface. Then we have the solid in solid, we have the mixture of alloys and colored glasses. Then we have liquid in solids, we have the example of hydrated salt. Number of hydrated salt, they contain liquid in lesser amount. Then we have third type of solutions, they are called as gaseous solutions, where medium or solvent is gaseous. We have the solid in gas, dust particles suspended in air, or coke particles, the thin powdered particles of coke, they are suspended in air. Then we have the liquid in gas, the water vapor suspended in air. Similarly, we have gas in gas, so gaseous solutions. Here is a mixture, a very good example of this. So these are the two methods of classification of the solution. Then we have the division on the basis of particles. We have classified the known substances. There was a division after this. The size of the particle in case of the solution, it varied from 100 to 100 nanometer or even more than that. Then it was seen that there should be the different classes of solution on the basis of size of particle. Thomas Graham was the first scientist who classified the known substances into two categories depending upon the behavior of the solution, their taste and their appearance, occurrence. So what is crystalloid and what are colloids? So second, depending upon Nature of solutions. The substances were divided into two classes by Thomas Graham. He was the scientist. So first class was crystalloids. The substances which are obtained from the nature in crystalline form, they are water soluble, their solutions are transparent, and they cannot be filtered with ordinary filter paper. They are crystalloids. Examples are the sugar, NaCl, KCl, all salt, they come in this category. Then we have colloids. Colloid means it is made from two words. Cola means glue. Colloid means like, glue-like substances. The substances which produce glue-like, the gum-like solution when they are mixed with water, such substances they were named as the colloid. But this division was later on discarded because the same substance could serve as both in different medium. For example, NaCl, it could serve as a crystalloid in water when it is dissolved in water, and it serves as a colloid when it is dissolved in benzene. Similarly, some substances they behave as crystalloid at low concentration, but at high concentration they behave as colloid. For example, we have soap solutions. If soap solutions are dilute, they will behave as a particles of true solution. If they are concentrated, then they will behave like a glue-like solutions, or they will behave as a colloidal solution. Therefore, this division was also discarded later on. Then division was proposed on the basis of size of particle in the solution. On the basis of size of solute particle in the solution. So substances they were divided into number one, true solutions, colloidal solutions. Then we have suspensions. Here size of the colloidal particle, that is less than 1 nanometer. Here size of colloidal particle is 1 nanometer to 100 nanometer. Here it is greater than 100 nanometer. Second, cannot be filtered. With ordinary filter paper. The particle passes through the pores of the filter paper. Cannot, we cannot. They do not show Tyndall effect. Tyndall effect is the scattering of the converging beam of light when it is passed through the solution of a substance. So they will not show the Tyndall effect. They do not scatter the incident beam of light. They show Tyndall effect. They also show. Then Brownian movement. Not predictable. They are predictable. Again they are predictable. Due to heavier particle, they are again less predictable. Brownian movement, they are less predictable in nature due to their heavy particle. Then diffusion. Fifth property is diffusion. The particle of true solution, they diffuse rapidly, while the particles of the colloidal solution, they diffuse slowly, and suspension, they do not diffuse at all. Filtrability, we have already seen. They can pass through ordinary filter paper. They cannot. Then appearance, they have clear appearance of their solutions. They don't have clear appearance. they have opaque appearance. Then we have the visibility. Particles are not visible in case of the true solutions. They are visible in colloidal solution, but they are highly visible in case of the suspension. Then we have the stability. These solutions are highly stable. The solute particles heavily hydrated by the solvent particles. Then they have less stable. They are again least stable at all. So this is regarding the division on the basis of the size of the solute particle in the solution. The substances, they were divided into three categories: true solution, colloidal solution, and suspension. And then we did the homogeneous and heterogeneous solution. We have already discussed that. Homogeneous solutions, they are having the same composition throughout. Heterogeneous, they don't have same composition, and they have the same properties throughout the solution. Homogeneous solutions. Heterogeneous, they do not have same properties throughout the solution. There are no visible boundaries between its components in the homogeneous mixture, but in heterogeneous mixture there is a visible boundary between the components of the solution. Example, we can say the sodium chloride dissolved in water, or ethyl alcohol and dissolved in water. These are the homogeneous solutions. And then we have gunpowder, iron filling, and sulfur mixture, that is called as heterogeneous mixture. So this is all about our first lecture of the second unit. Then we'll start with the next topics in the next lecture.